Okay, so this is the screencast for worksheet 10. Let's go through the discussion questions first. So first off, we have the reaction between N2O4 and NO2. So one is pure yellow and one is dark brown. We have also done this experiment in the practical. Okay, what's meant by the term dynamic equilibrium? This part you just copy your notes. But mainly, it is when the rate of forward reaction is equal to the rate of the backwards reaction. Okay, which color? Okay, so the rate of the forward reaction is equivalent to the rate of the backward reaction. What effect, if any, would an increase in pressure have on the composition? So you must first check what are their state symbols, gas and gas. So on the left hand side we have, let's use blue. On the left hand side we have 1 mole of gas, on the right hand side we have 2. So when I increase pressure, then it should favor, equilibrium will shift to favor the side with less number of moles of gaseous molecules, which in this case should be towards the left hand side. And hence, there's an increase in the production of N2O4 and less NO2. Okay, see, the figure below shows what happens when 3 identical sealed glass tubes containing a mixture of N2O4 and NO2 are kept at different temperatures. Explain whether the forward reaction is exothermic or endothermic. Now, you see that when temperature is increased, from here to here, temperature increased, right? It became darker in color. So, comparing the two, NO2 is darker in color. So, when temperature increased, more NO2 formed, which means that favored the forward reaction. Okay, then you must think, whenever there's an increase in temperature, what type of reaction does it favor? Is it exothermic or endothermic? Okay, when there's an increase in temperature, you want to favor the side that takes in heat, the reaction that takes in heat, which is endothermic. This tells us that, based on these two statements, favor the forward, and that is endothermic. If it tells us that the forward reaction is endothermic, because it's written here, increase in temperature cause equilibrium to shift to the right and making more NO2, which is dark brown. Okay, question 2. Each equation shows the reversible gaseous reaction. Complete the table to show an effect of increase in pressure on the amount of products at equilibrium. You have to write decrease, increase, or no change in the space provided. Okay, so on the left hand side, I think so these are all gaseous reactions. So that's the premise. If we look at this, on the left hand side we have 1 mole, on the right hand side we have 2 moles. Okay, when there's an increase in pressure, it should favor the left hand side. So it should shift in this direction. Okay, the amount of product should decrease. Let's look at the second one. A plus B, each 1 mole, so there's 2 mole versus 2 mole. There should be no change when pressure is changed. Lastly, 4 plus 5, 9, 4 plus 6, 10. So, when there's an increase in pressure, it should favor the left hand side. Again, there's a decrease in the amount of product at equilibrium. 3. Haber process for the production of ammonia from its element can be represented by this equation. Haber process again. Okay, in the process, a mixture of nitrogen and hydrogen are passed over catalyst. This is then removed from the products. Unreacted gas passed through reaction vessel again. From time to time, argon gas is removed from the reaction vessel where it accumulates. State the catalyst normally used in Haber process. This is a recall question, so it's iron. 2. What are the sources of nitrogen and hydrogen? Okay, Nitrogen is obtained by fractional distillation of liquefied air because nitrogen comprises of 70% of our atmosphere. Then hydrogen is made by firstly reacting methane with water or from cracking hydrocarbons. Okay. The second part, we'll look at it in organic chemistry. You'll see that it is a side product from cracking. Part 3, why is ammonia removed from the products before passing the unreacted nitrogen and hydrogen over the catalyst again? Okay, I think we explained this before. So when I remove the ammonia, equilibrium will shift towards the right to increase the yield of ammonia production. B. The figure below shows the percentage of ammonia in the equilibrium mixture under different conditions. Wow, this graph, so beautiful, right? A bit hard to see, but it just says that percentage of ammonia equilibrium. Okay, so it's in percentage from 0 to 100. Okay, which temperature produces a larger percentage of ammonia in the equilibrium mixture? Okay, it should be the one that's closer towards 100 lah, so it's 200 degrees Celsius. So answer for part 1 is 200 degrees Celsius. State a disadvantage of using a temperature that's lower than 500 degrees Celsius. It will be that the rate of reaction is slow. Part 3, which pressure, 50 or 150 atmospheres, produce a larger percentage of ammonia in equilibrium mixture? State a disadvantage of using pressure greater than 200 atmosphere. Okay, 50 versus 150. If you draw a dotted line out, okay, 500 one is not very obvious. Okay, you can see that. Let's say at 300. 150 atmospheric pressure will give you more ammonia. Okay, state a disadvantage, you can say cost, you can say safety concern. Okay, because whenever there's a huge pressure, there's always a greater concern that it may explode. And it costs a lot more to maintain a higher pressure than a lower one. Okay, let's get assignment questions. Question 1. In the contact process for the manufacture of sulfuric acid, sulfur dioxide is converted into sulfur trioxide. Now this came out from my uni exam, but I didn't study it because I thought, memory work, uni won't test, but it came out. So I just lost like 4 marks because I thought the uni lecturer won't be so lame as to test like memory work. But he did, so it tells you that it's important to study your stuff. Okay, so let's just read. A mixture of SO2, O2, and SO3 was allowed to reach equilibrium. Subsequently, temperature raised. Okay, so first, you must. This is about temperature. Temperature was raised, so we increase temperature. How does it affect the composition of the equilibrium mixture? So first, we must note delta H is negative. This tells us that it is exothermic. Okay, if it's exothermic, does it take in or does it give out heat? Okay, it means that it gives out heat. When temperature is increased, should we favor exothermic or endothermic reactions? Okay, to counter the change, I must favor a reaction, the side that absorbs some of the heat. So it favors the endothermic reaction instead of exo. Hence, it favors the backwards reaction. Okay, so we'll have less SO3 being produced. As the forward reaction is exothermic, when we increase temperature, you shift equilibrium to the left to favor the backwards reaction that is endothermic. So remember, when we increase temperature, we favor endothermic reactions. In each of the equilibrium processes below, use the Chatelet's principle to explain the observations described. A. When potassium nitrate dissolves in water, the temperature drops. if a saturated solution of potassium nitrate at 100 degrees Celsius is cooled to room temperature, crystals are formed. Okay, so first, let's look at the delta H. It is positive, which tells us it is endothermic. Okay, if it's endothermic, I need to have an increase in temperature to favor the forward reaction. Okay, the dissolution is endothermic, hence temperature is dropping. Okay, at 100 degrees Celsius, I can dissolve more. So, a decrease in temperature from 100 to room temperature favors the backwards reaction, which is the backwards reaction. Okay, and hence the position of equilibrium will shift to the left to form more potassium nitrate crystals. Did I go through this in the practical? I think I did. Okay, never mind. Let me just go through again. Okay, when a small volume of concentrated solution of sodium sulfate was added to a saturated solution of calcium sulfate, calcium sulfate. So when I add sodium sulfate to calcium sulfate, I'm adding more sulfate ions. So when concentration of this increases, sodium sulfate provides sulfate ions. So when the increase in concentration of sulfate ions, it will cause equilibrium to shift to the left. Okay, that will cause more CaSO4 to precipitate. 3. The acid dissociation constant, Ka, measures the strength of an acid. In aqueous solution, the general equation is written like that. Okay, the name and the Ka are shown below. Okay, so what is the relationship between the strength of an acid and the Ka value? Okay, so how do you do this? You can see that there are some acids that you know, right? You know HCl. It is a strong acid. And you see that the value is much greater than the rest. So you can see that when Ka is high, that means the stronger the acid. Sulfuric acid is a dibasic acid. Hey, why does it keep popping up? Okay, you can also see that sulfuric acid has a quite high Ka as compared to the rest. Quite high lah. Write a chemical equation for the dissociation of sulfuric acid to form the hydrogen sulfate ion. So what is the hydrogen sulfate ion? It is HSO4 minus. So you must come from this to become this. It's quite simple. Just remove a hydrogen ion. Part 2, with reference to the K value, compare the ease of formation of the two H plus ions from a H2O4 molecule. So the first dissociation, the first dissociation is this. The second dissociation is this. From here to here, you can see that the value of the Ka has decreased by a lot. Okay, 10 to the power 3 to 10 to the power minus 2. So it is easier, therefore way easier to lose the first hydrogen to form HSO4 minus than it is to lose the second hydrogen and form SO4 2 minus. So the K value in 1, which means in here, is higher than for the dissociation of HSO4 minus to form another H plus ion. Hence, it is easier to form the first H plus ion. Lastly, using the Chatelet's principle, explain the effect on the concentration of ethanoic acid molecules when HCl is added to a solution containing ethanoic acid. Okay, so what we need to say here is, because ethanoic acid, as you know, is CH3COOH, its dissociation can be represented in this equation. Okay, so when we add HCl, this increases, when the concentration of this increases, it means it favors the backwards reaction, and there are less CH3COH that will dissociate. Okay, or you can say the opposite way, which is written here. Hydrochloric acid is a stronger acid, and when added, it causes the H+ concentration to increase. Okay, you can just say that HCl causes the H+ concentration to increase, which shifts the equilibrium to the left and causes either an increase in the concentration of ethanoic acid molecules. Oh yeah, they ask you to explain the effect of the concentration of ethanoic acid molecules. Yeah, so this is the answer. Because it shifts towards the left, there are more ethanoic acid molecules. So that's the end of worksheet 10. I hope you get a clearer idea of reversible reaction now. If you don't, please consult me or email me your queries. Thank you.